All right, we are now on our second module, and this time we are going to talk about statistical intervals and hypothesis testing. This is somewhat like a continuation of our previous module, specifically the last part, wherein we introduced the core concepts of statistics. Okay, specifically more on the descriptive statistics. Right. So now for module two and even for the next module, we're going to talk about inferential statistics. Okay, so we allocate two modules for that. And here we are going to see what the statistical intervals mean. What does probability have to do with statistical intervals, and how they are related to what we call hypothesis testing, right? So without further ado, let's begin. Okay. Um, Before we read the definition of statistical inference, I'd like to have a quick introduction by giving an emphasis on these two terms. As future engineers, we are bound, we are expected to be able to practice um, our profession um, in connection to these methods. So basically, how we do our things must be in line with the scientific method or the engineering method or the engineering design process. So these two are very similar, if you have noticed. Um, but number one, the scientific method, we want to answer something, answer how the world works. We want to answer um, we want to understand some scientific phenomena, okay, especially involving natural laws. Okay, where in engineering method, we use it to solve a certain problem. Okay, so that's why in scientific method, we start by asking a question, we do the background research, and then we construct a hypothesis. Right, so this is where statistics comes in because normally statistics is a key part of conducting hypothesis testing. Okay, especially inferential statistics. Okay, so once we have the hypothesis, we test that hypothesis normally using an experiment. Okay, for engineers, we are also especially for this course for engineering data analysis, we are focused more on conducting experiments. Okay. And then once we are done with the experiment, we check if the procedure is working. If no, we reconfigure our experiment. But if it's okay, then we can proceed with analyzing our data and we draw our conclusions. Okay. And then once we are done with that, there are two possibilities. The results align partially or not at all with the hypothesis. If that's our result, then we go back to our hypothesis. So we using our experimental data, we now have a background research for our new project, or we can now ask a new question, form a new hypothesis, or we can experiment again. Probably we can repeat the experiment in another scenario, like in another setting, another place, another time, another type of environment. Okay. So another set of parameters. Yeah. Um, but if our results align with hypothesis, then we can now communicate the results. By the way, either way, we communicate the results. Okay. But if our results align with the hypothesis already, then there's no need to repeat our experiment. Okay, there's no need to reconfigure our experiment or construct our hypothesis again. Um, okay, so that's regarding scientific method, our goal is to answer that question that we have from the very beginning. On the other hand, we have the engineering design process or the engineering method, wherein we start by defining the problem first. So we have to understand the problem. We make sure we are trying to solve the right problem. Okay, so we define it well, and it can be helpful if we can do some background research, like the review of related literature. And after that, we can communicate with our stakeholders to specify the requirements. So we can talk to our clients or target beneficiaries. We can talk to some experts or subject matter experts, SMEs, or we can gather the team to come up with the specifications that your system must uh, convey or must follow. Okay, so usually for us, we solve the problem by providing a system. Okay, that's a common option for us, but there are many other ways to solve the problem. Okay, but for students, most likely we do that by creating a system. Okay. Once we have our requirement specification, we brainstorm, evaluate, and choose the solution. So usually we talk to experts also and our stakeholders, and of course we talk with the entire team, discuss it. There are many possible solutions, but we have to analyze which one is the best, which one suits well with the given constraints, like our time, our budget, and so on. Okay, so once we have our solution, we of course we don't just accept that. We have to develop the prototype for that so that we can test that solution. Okay, so during testing or when we are testing the solution, we normally conduct a hypothesis testing. So actually, we to test our solution, we ask a question: Is this solution okay, or is this solution effective in terms of these parameters? Okay, so we are actually asking a question. That's why from here we conduct hypothesis testing, starting with asking that question, and then the rest are history. So once we have the results, we go back here. So we have the answer. Once we have the answer, either the solution meets the requirements, so we're done. Problem solved. But if not, if the solution does not meet the requirements, or whether it only met partially, um, so we go back to somewhere. Like based on the results and data, we make design changes, either our design change or maybe our prototype must be reconfigured or rebuilt. Okay, or maybe there's something wrong with our testing. So let's check. Okay, and then review our data, and we do it repeatedly until our solution meets our requirements. Okay, now if you wonder when is the time that we might involve engineering design while we are conducting hypothesis testing. So okay, so now this time it's reversed. So if actually here, when we are testing with an experiment, sometimes we have to develop a certain prototype so that we can conduct that necessary test for proving or disproving our hypothesis. Okay, sometimes to do this, to test with an experiment, we have to come up with a prototype first. So usually for students, this is the process. We ask the question, do background research, contract hypothesis, and then we test. Before we can test the experiment, we go to the other side first. We build our prototype. Okay, we define the problem and so on, and then if the problem or I mean the solution meets the requirements that can solve the problem, then we communicate there. So as we gather the, of course, we can now use our prototype for the experiment. Okay, so That's how these two things are connected. And for engineering people and students, they are both people. Uh, it's very common that we usually use both. Okay, especially when we are developing a certain prototype. Okay. Now how do how does statistical inference relate to this? Again, for scientific method, of course, we have the hypothesis testing. But for the engineering method, usually for testing the solution. So there are many ways to do this. Maybe we can conduct a correlation test or a simple descriptive test. It depends. It depends on our specific scenario. Okay. Basically, there's stat in both. Okay. There's statistical inference. So what is statistical inference. It's the process of drawing conclusions or making predictions um, about a population based on sample data. So instead of concluding or doing the test for the entire population, we can do is to test a certain portion or a sample of that population. Okay, and whatever our conclusion regarding the sample could it could also be used to generalize the entire population. Okay, so for example, if we conclude that all the components that we manufactured, all the resistors, for example, all the resistors that we manufactured range um um have a 5% tolerance only or a 5% deviation from the target value. For example, it's 100 ohms. So let's say 5% deviation. It could be 100 plus 5% or 100. The range could be from 100 minus 5%. So that would be 90 9.05 0.95 up to ohms up to 100.05 ohms. Okay, I 5%. So 5%, so 5 exactly. So either from 95 ohms to 105 ohms. Okay, so 5% of 100 is 5. All right. So we just subtract that. So when we subtract that, that would be our minimum or the lower limit. And when we add that 5%, that would be our upper limit. Okay. So um if our sample has that kind, or if our sample only falls within that range, then most likely our entire population will also fall on that range. The question is how much sample do we need to have some so that our such assumption, such estimation will be valid. Okay, so that's where what we're going to talk about in a few slides. In the meantime, take note that statistical inference involves using statistical techniques. So we're going to introduce some of them later and methods to analyze the sample data and make inferences about the larger population from which the sample was drawn. So before we can conclude about our population based on our sample, we must perform some statistical techniques and methods first. Okay, and in statistical inference, we do two things: the estimation and then the hypothesis testing. Okay, so that's for the first part. We're going to talk about estimation in the next.